there. So we are back thinking about talking about the A to D conversion rates. So so for example, one configuration like that, conversion mode is now continuous, meaning that it just keeps running, and then basically the continues running as fast as it can. And here's the conversion sampling rate, for example 10,000 samples per second. That gives you 16-bit resolution. That's fine. That's sigma delta, quite moderate the sampling rate. Input range, actually, well, that depends on your voltage, but anyways, it's the well, it's plus minus, and this reference actually is to the reference voltage. Reference voltage here is 1.024, so basically that will give you the 0 to 2.048 volt. And well, you can check also these the references, but anyways, when you copied your setting, well, you copied this example, then fundamentally these values are already set. But anyway, something that which is not set is the interrupt. There's end of conversion output on that delta sigma. Delta sigma, the A to D converter. Let me check it. Quick look here. And the command internal. Okay, yeah. So nothing to see there. But anyways, there's end of conversion output, meaning that if you, in case you want to interrupt on it when the conversion is done, you would basically then need to add a interrupt component here, like that. Now you basically have the interrupt service routine for when you click the generate application. So that answers the second question. Then another question is about how to time your application. So now, if you have an interrupt service routine on each end of conversion here, then you can actually inside of that one start bookkeeping of the input values of A to D conversion, or calculating the running sum, and also calculating the amount of this data in the running sum. And basically then you have the okay, now you have the inter-service routine, and inside of that one you do have a place to put your own code, which is here. No, not there. Oh, there. Place your interrupt code here. So if you have interrupt service routine given by this PSoC creator, then there is the interrupt service code that you can actually just fill in on that ISR, on the corresponding ISR. Okay, so you can put your code here, or read what it says above somewhere. Let's see. You can also make your own function prototypes for that. So there is a function named ISR1 start X, like start external code, basically where you then have the function definition first, exactly like that, CYISR, and then your function name, and then function prototype on the top of the code, and then instead of having the ISR1 start, you can start your own externally defined interrupt service code routines. I prefer this method actually better. But anyways, the if you have an interrupt service routine, then basically you can find always the place there that you can hard code your own interrupt service routine code. Okay, that answers the second question, which is about, I cannot find the code section of the ISR where I can write my own code. First, if you are using A2D conversion interrupts, make sure that you are getting the interrupt or have the handler for it. So delta sigma has the end of conversion output that can be actually used to trigger an interrupt. Okay, which is a separate component. Okay, the other one was about now the how to set the sampling rate, meaning I'm guessing that this means the 2 samples per second sampling rate. Well, this is one way of doing it. There's plenty of the ways you can do it, but this is my favorite. You add a timer. For example, low 1 kilohertz clock rate timer, and make the period 500 millisecond, interrupt on terminal count, apply, okay, then basically hook up again the interrupt module here, interrupt component, well, from the interrupt source, or actually you could also put the directly to the interrupt the terminal count, giving the interrupt there. But anyways, that's the way you get an interrupt twice a second, and between those twice a second interrupts, you will be just adding the values into a variable, adding calculating the sum, boxcar sum during that half-second period, and updating also this count, how many values there on the sum. So when that period is done and you get the interrupt, you calculate the average and null the values. And thinking of the side effects also, use either flags or disable interrupts when you are calculating this division and updating those values globally. Otherwise you may actually have the side effect. Okay, so that's the explanation how to do this exercise and do the calculations of how many doing the that 2 times a second sampling rate. This, can I use ADC delta sigma 1 IRQ as ISR? I think you can. Let's see, what does it have it there. There's a question about, okay. Okay, default handler. Yes, you can. You can actually have this one. Okay, I didn't read the manual that good, so basically you can either put it here or I think this is a better since that you do not need an extra interrupts handlers on your design. So basically you can get rid of that one as long as you have the interrupt property clicked for the timer. Oh, not timer. Ah, wait a minute. No, timer. Why did I do that one? Timer. Timer you need. Ah. Okay, timer you need, but this ADC does it actually. Okay, yep. I think you can use that one. Let's see if it actually works that way. So if I make generate application, do I still have that functionality there? But yes, if there is a interrupt service routine already which does the trick, yes, you can use it. As long as it does the job. Ah, there was a. I need to quit one of these questions. How unfortunate that we do not have a chat where you can review every single question anytime and so on. Yes, we do have. Teams. Use the Teams. I have been basically. Sorry, that was everyone. We have that one. It's on Teams. Just a moment. Teams here. Not summer school. Yep. PSoC Design has these topics. Each of these on topically. Data acquisition commands. There is one question there. Hello, I have a question about JSON. Okay, I have answered that. Timers and interrupts. Yes, I have answered quite many of those. And actually, there have been also, like in fundamental, no, not fundamentals. The timers and the interrupts, also the students also. Nazir has answered a question, and I also put a like reaction since this is correct answer in my opinion. So if you have any questions, post those there so the other students also can see them and can help you. And by the way, for example, this one is actually several of those this is a whole discussion having the same problem of one of those topics. So please keep putting the questions on that these posts for the PSoC design, the team space. Okay, so any not unanswered questions? Floating point numbers. Okay, printing the floating point numbers. That requires a little bit of investigation. And I think okay, 2 more messages. Renee always get 255 and 7 as temperature read from the sensor. Rest works fine. Okay, 255 means that it's all bits are up, meaning that the sensor that is strange, very strange. Is your address correct? That's one question. First question. Have you checked that you get ACK? Another thing to check is what took me actually few, well, not hours, but say tens of minutes. I was, why I'm not getting any acknowledgement, why I'm not getting anything. Check your version code. If you have this TO220 package, check that code, since basically if it's, let's see, code actually also defines the address. You have 5-volt device and the basic address depends on the code you find from the package. Okay, I can read the ROM, I can read and write to scratch pad. Oh, one wire. One wire. Okay, one wire. Sorry, Renee, about that one. So, yeah. One wire. Exercise 5. I have a feeling that I know. Can't be sure though. If you can read and write the scratch pad, do you notice that actually the temperature information is unique? Okay, the temperature is on the first 2 bytes of the scratch, but you have to actually read the whole scratch pad to access it. Otherwise you get funny numbers. Complete scratch pad. What else I could actually then just read and write goes well. Okay, byte 8, cyclic redundancy check. Is your data valid? What you're reading, are you actually reading the real data, but are you reading just the garbage online? CRC actually, just a moment. I think there is the cyclic redundant check. You can, since this was on CRC, what does it say about the CRC? GRC generation section. 9th point, okay. Okay, it's basically a bit operation. Let's see. I think. Yeah, that's a good. Suman, that's excellent. Excellent. Let's continue exercise 5 on Teams and discuss later. Yes, yes, I agree with you. Exercise 3 is the primary thing, and actually, yeah, maybe 15 minutes more. So let's concentrate on the exercise 3. And yeah, thanks, Marcel. With the template of exercise 3, we should calculate an output arithmetic mean, but with the template, the mean is already with the potentiometer test. Oh yeah. Actually, yes, yes, you can rewrite the whole thing if you want to. So using that exercise as template, it's as in any templates. Feel free to modify it for the purpose. Let me open that template myself. Or, well, basically new project. Not that one. From code example. ADC and UART code example. Don't worry about the fonts. If you get complaints about fonts, don't worry about those too much. Okay, blinking head, PSoC design courses, and that's the one. And example, I'll just change the exercise 3. So that as a template there. And read these manuals so that understand what it is. But what I would do for the exercise 3 is just first make sure that it works. Put that potentiometer there and see that you get the millivolt values on printed on UART. But otherwise, actually, let's get rid of some of that stuff. For example, on the top design, then go to main, yada yada yada, blah blah. Change some of that. That's okay, since actually there it's as the commands for the interface that still can be there, but basically anything else can go. Nothing is sacred here. So for this exercise, you can for example, here at some point you start the enable the ADC delta sigma interrupts. I think they are disabled by default, but you basically can then, before starting the conversion, what you should be doing, come on, my computer is sluggish. Okay, there we go. Enable ADC interrupt, and then write the interrupt service code for the this delta sigma, so you're not well, yeah, and write interrupt service routines for that one. So to get that part working, of course you can also, within these parameters what I have given you, actually you can go to the delta sigma and already in here, well, that's 10 kilohertz range, that's just fine. Let's see what else. Yeah, that's fine. Check the parameters. You can change the parameters if you like to. Again, then of course need to change that one, and but anyways, we'll start working with it. So there's no sacred things what the examples does. As long as you use that as a template, then just go ahead and start modifying. What is important on this, if any of the exercises, is at the end of the exercise. Let's see, where's the exercise 3. At the end of the exercise, it should work. Something similar to this video. Third exercise is about A to D converter. Mute that one. So there is a demonstration of what should happen on each of these. So warming up in continuous mode on the top level here. Let's see. Spotlight there. Not that one. Sorry, it went over. There we go. So check what I'm expecting from the video, but it actually, it should be quite loud and clear also in this one. So exercise 3, ADC sampling, modify the project, analog temperature sensor instead of the this potentiometer, and well, change the conversion rate if needed, but actually that 10,000 is okay. And then generate your own code segments there to calculate the time average data A with new downsampled rate. And I already visited a little bit, but let me, what I would do, I would actually add here a timer. Just timer like that. Take the clock, existing clock from internal low oscillator. Now I have 1 kilohertz clock coming into the timer. Make it 16 bits to have interrupt on every 500 milliseconds. Yes, interrupt interrupt. Now I need to add here the interrupt and connect the dots. Oops, what happened? Connect the dots and make this one to interrupt on terminal count. There you go. And I can actually call that one, for example, ISR 0.5S. Or 500 millisecond to have it a better name. Okay, there we go. So now I have the mechanism to have the sampling at that 2 samples per second. And then there's the ADC delta sigma, which is interrupting if you allow it to interrupt on the interrupt on ADC ready or the conversion ready. So every conversion you oh, digital clock dividers. Well, something went wrong here. Can you only use digital clock dividers? But anyways, the fundamentally this is how you do it. Maybe I need to do with 1 kilohertz. There we go. I got an error message. Timer clock. Now it should get the generation better. Okay. And rest, of course, you need to do the coding. One idea, coming back to this, the first session, this the structure of the code. I would actually here again do something like this. Instead of having lots of code here, you would just call one single function which has all of this inside of them. It makes this main function more readable. On the main function you have the most important stuff, so what really happens on the code. So encapsulate everything else inside. Aha, Nasir, excellent question. Which interrupts should I disable while calculating the average? You should disable everything that can actually cause you trouble. So calculating average, it's just you have first the running sum and the number which tells how many values there are on the sum. First you need to wait until you are sure that you are not at the middle of this A to D conversion interrupt service routine. So you need to wait until the interrupt service routine finishes. Since you cannot guarantee that your timer interrupt does not happen at the middle of the this A to D conversion interrupt service routine. So practically you need to check that if that this ISR has already finished, the A to D conversion ISR has finished. You can use separate flags for that, or actually there are also these API functions to check if that was done already, and then okay, which interrupt you, well, you can either prevent that the interrupt happening, the A to D interrupt happening, or you can also set a flag that if you are at the middle of the calculation, then on this A to D interrupt, you basically don't update those values on that round. Okay, so that gets a little bit complicated, but that's something you need to anyways ensure on your embedded systems programs, that the side effect, classical side effect, does not affect on your result. So easy way, disable all interrupts within an interrupt service routine, then you know that after that there will be no changes on those values. Of course, then you also need to check that it's not at the middle of the ISR somewhere else. Wait for that one to finish and then do the calculations and enable all interrupts. That's the easy way out. Although it may have also some other effects on what it affects, but anyways, with the hardware I mean. But that's the easiest way. Hey, I gave a good answer. Okay, anything else on exercise 3? So just filling something here now, so void int or void. Haha, of course I need to put those as global variables. Some encapsulation now. Yeah, still functional code. JSON's part. Okay, that's easy. So this exercise actually, let me show you that. What does it do? It prints you the strings at 5200. Open that one, which basically on my PuTTY terminal it looks something like that. Not continuous, but there. So oh well, single. There. So it has some values. Well, I don't have any temperature sensor there or any other source, but anyways, it gives you string values. Instead of these strings, I would like to see strings which basically are not bad. Which looks like, instead of those strings, I would like to see strings that look like, say, ADC value equals to 23.2 centigrade. Actually, I don't need that one. And then the well, that's JSON. So do the that formatting of the output just as a JSON data. If you are familiar with the, say, LabVIEW or MATLAB or some other programs, the JSON is actually quite general format, so you can then easily use this comport input, for example, as a data source to your LabVIEW program. I think you are using LabVIEW on some exercises. At least it used to be a few years back there. Or if you are familiar with MATLAB, there are plenty of different functions. Well, there are some functions that you can import this data from other sources, including the serial port directly to the program, and then actually just start analyzing the data. Or, well, you can also have that one showing up on a HTTP link if you have if you are basically a master of some web page. It's not that hard actually to include the make a web page as a data repository for this IoT system. Well, I call them embedded systems. There's very short step from this embedded system to provide IoT with the cloud data and such. But one step on the way is that you need to understand the JSON format. I'm not sure if there are these corrections. I always have to check. check JSON. JSON.org. Okay, yeah. White space, comma. Oh, sorry, it's not equal sign, it's actually not semicolon, colon sign. There. So that's what I mean about the JSON format. Remember, JSON is not a file format. It's a presentation format of strings. Nothing to do with the files. They can be also on the streams. Any other questions? Okay, if there are no more questions, I will close my session. You can still keep hanging on and answer each other's questions on the chat room, but I need to get some break now. So thank you for attending. You have a great audience, the best today. And see you next week. And the next week meeting, actually, I think it was even it was at a little bit different time again. Let's see. It's at 1 o'clock Finnish time, which is 12 o'clock German time. Yes, so next week we have the online meeting again on Tuesday. I will send you again the link to that one, and I will be also uploading these two questions and answers videos to the internet as soon as I will finish up here. Thanks and bye.